Okay, this video is hopefully a nice straight to the point video on graphing polynomials. Anyways, notice this polynomial, guys, is a cubic function, right? It's a cubic function. Okay, see that 4x cubed right there. Now, before we proceed any further, guys, what I want to point out is, and actually I'll do it here on the side, but one of the things hopefully you're learning in your class is, if I have a typical function, let's say like a x squared, well, that's a parabola, right? It's going to look like this. If I have an equation like a x cubed, it's going to look like this. Okay, almost like a S-shaped. Alright? Now, what would happen, though, if it was negative x squared? Well, instead of opening up, it would open down. So that's what the negative is going to do, is it's going to flip it down. Okay? What about the x cubed? If I make it negative, you have to understand it flips and goes the other way like that. So it S's in the other direction. Okay? And then, upon further analysis, you guys should have learned as well that if I did an x to the fourth, well, it really looks like an x squared, except it's a little bit more square near the vertex, okay? In other words, any even power, okay, is going to point up on both the left and right extremes. If it's negative, then it points down. Like this one right here. See, this would be a negative x4 if I kind of squared off the vertex there. That would be a negative x4. And the same thing goes with odd functions, guys. If I, for example, did an x to the 5 power, right, you'll basically see it go up on the right extreme and down on the left side. A negative would do the exact opposite. It would go up on the left extreme, or negative extreme side, and then down on the right side. But anyways, getting straight to the point here, guys, what we have here is a 4x cubed, right? And so because it is a x cubed, we know it's basically going to go like this on one side, down like this on the other side. And that's the one thing you need to understand. Okay? But let's get to graphing it. So here I have it rewritten again to give me some more workspace. But the thing to also understand, guys, is sooner or later, hopefully you'll be in trig pre-calc and learn about derivatives, which will really help you do these more complex, higher ordered polynomial graphs, okay? But we don't have that power in front of us. So you're just basically getting the general feel of it. Now, the one thing you should be able to do is factor by grouping, okay? So I'm going to take the first two terms here and do a GCF factoring on it. Hopefully you notice the 4 and the 12 has a GCF of 4, right? And notice both terms have an x in them. Actually, they both have an x squared in them. So 4x squared is what we would call my GCF, the greatest common factor, okay? Greatest, let me write that a little bit neater here. Greatest common factor, GCF, okay? And so let's see what else we have. Well, hopefully you realize an x times with the 4x squared will give me my 4x cubed. We need a minus because of the minus right there, right? And we need a 3 because 3 times 4x squared is that 12x squared term. Okay? Now let's bunch up the last two terms right there. Notice both 5 and 15 have a 5 factor in common. And the other thing that's a good habit to do is notice that minus in front there, guys. Let's go ahead and actually factor out a minus 5. Okay? And of course, hopefully you get x, because negative 5 times x is negative 5x there. And then you're going to get a minus 3. A minus 3 because minus 5 times minus 3 will give me that plus 15. Okay, so let me just clean up my little loops right here. So guys, here is factor by grouping. Now, of course, now look at our results. Notice how both of them have a x minus 3 factor in common, right? So we complete our steps by saying x minus 3 times is with 4x squared times is with a minus 5. And so here is the factored form of our original equation. Now let's use the 0 property. If I set it equal to 0, doesn't that mean that that right there must be a 3, because 3 minus 3 is 0. Now what about 4x squared minus 5? Let's actually solve that. 4x squared minus 5 equals 0, only if 4x squared equals 5. Basically all I did was do a plus 5 on both sides, right? Plus 5 plus 5. Okay? And now, don't I divide by 4? So x squared therefore equals 5/4. And finally, if I square root, because the square root is how we get rid of the squared power, right? We now know that x is plus or minus the square root of 5 over 4. Now we could simplify that many ways, guys, but let's just go ahead and use our calculator, okay? And if we use our calculator, I'm pretty sure the square root of 5 over 4 will become plus or minus 1.118 something. Okay, I already did that on my calculator ahead of time, guys. So notice, guys, we have two roots there, a positive 1.118 and a negative 1.118. And we also have the regular integer 3. We have 3 roots, right? 3 zeros is another way of calling it. All right, or 3 x-intercepts. But the bottom line, guys, is we have enough information to get a general idea of what's going on here. So in conclusion, guys, we know, again, where was our zeros at? 3. We had a 0 at positive 3, correct? Right there. We also had a 0, if you notice, at positive and negative 1.118. So I'm going to put a dot just past the positive 1 right there. Probably should be a little bit closer, actually, but close enough. And then I want one just past the negative 1, about right there. And based on what we discussed, does everybody agree? On the far left, we know it's going down. On the far right, we know it's going up, because that's what an x cubed does, right? It makes that S-looking shape here. Now, because we have a 0 right there, though, guys, logic tells us that this curve is actually going to loop up here somewhere. Now, we don't know exactly how high until we get in the calculus, okay? And then it's going to bend back down and cross right there at that 1.118. And then, of course, eventually has to bend back up and go through that positive 3 right there. So I got a little messy there. So let me do this over again. So we had negative 1.11 there, positive 1.11 right there, and a 3 right there, right? Okay. Get that a little bit better. There we go. And so here basically is a rough sketch of what's going to happen. Now, if you have any doubts, here is the real graph on Desmos. I actually use a program called Desmos, guys, which you should be familiar with. You should actually have that app on your phone, quite frankly. But notice, guys, did I not have a 0 at negative 1.118? Positive 1.118? And at positive 3? And you can see my graph is very close to this graph. Keep in mind, guys, I'm not going to know these max and mins here, relative max and mins. Really, I can't figure that out until unless I make a huge table, okay? But you'll learn how to find those much easier with derivatives when you get into trig pre-calc or calculus class. So guys, I hope I did a good job. Hope there's no real good questions or serious questions. I'll leave it right here on the screen since that's most of the work. Or maybe you should see the original graph right there. Okay, actually I'll leave it right here. Until next time, guys, bye.